In today's lecture, let's multiply with other bases. We'll start by using the standard algorithm. That's the algorithm you already know how to do. Before we do these questions, let's try something we already know how to do. Let's do 23 times 45. What you would do is multiply 3 times 5, that's 15, and you carry the 1 over. Then you do 5 times 2, that's 10, plus 1 more, that's 11. Then you move over to 4 times 3, that's 12. You put a 2 and you carry that 1. Then you do 4 times 2, that's 8, plus 1, that's 9. After you do that, you're going to add. You get 5, 3, and then 1 plus 9 is 10. So we get 1035 for our solution. So when you do multiplication, you multiply the rightmost digit here to the top 2 digits, and then you move on to the 4 and then multiply it to the top 2 digits. That's exactly what we're going to do with different bases. Let's try example 1. Now look, this is base 5. The only symbols are 0, 1, 2, 3, 4. That's the only symbols we're allowed to use. Anything larger than that, we'll have to convert it to base 5. So let's multiply. 3 times 4 is 12. We cannot have 12 in base 5. 12, when I divide it by 5, is equivalent to 2 remainder 2. So 12 is 2, and then we'll carry that 2 over. Then we'll multiply 3 times 3, that's 9, plus 2 more, that's 11. 11 does not exist, so we'll convert it to base 5. That's 2, remainder 1. So we'll put a 1 here, and then we'll carry that 2 over. Then we're going to repeat the process. We'll erase the numbers on the top so it doesn't confuse us, and then we'll go to the bottom. We will go underneath the 2 this time, and then multiply 2 times 4. 2 times 4 gives me 8. 8 divided by 5 is 1, remainder 3. So we put a 3 down here, and then we carry that 1 over. Then we'll do 2 times 3, that's 6, plus 1, that's 7. 7 divided by 5 is 1, remainder 2. So we have a 2 here, and then we'll carry that 1 over. And now we just add. This is a 2, this is a 4, this is a 4, this is a 1. So our answer is 1, 4, 4, 2, base 5. And this is our solution for question 1. Now let's go to question 2. Again, it's the same process. We can only have the symbols 0, 1, 2, 3, 4. That's it. There's no other symbols allowed in base 5. 1 times 3, that's 3. 1 times 2, that's 2. 1 times 1, that's 1. Multiplying by 1, pretty easy, no problems. Then we'll do 2 times 3. Well, that's 6. 6 does not exist, so let me convert that to base 5. That's 1, remainder 1. So we have a 1 here, and we'll carry that 1 over to the top of the 2. 2 times 2, that's 4. Plus 1 more, that's 5. 5 does not exist. That's equivalent to 1, remainder 0. So we have a 0 here, and then we'll carry that 1 over. 2 times 1 is 2, plus 1 more, that's 3. Then we can add. Now be careful, you want to make sure you're stacking it in the right place. I start underneath the 1, then I'll start underneath the 2. So be careful with the stacking. Let's add. We have 3, 3, 1, 3. So our solution is 3, 1, 3, 3, And don't forget your base here, base 5. In example B, let's use the lattice algorithm to multiply the following. In the lattice algorithm, it's going to give us the exact same answer as in part A. So let's do the same questions again, but this time using the lattice algorithm. So let's start example 1 with the lattice method. I'm going to start by constructing this rectangle. Now inside this rectangle, I'm going to split it into 4 and then split it again by diagonals. The number on top is 34, we'll write 34. The number on the bottom is 23, so I'm going to put 23 here on the side. Now I can begin to multiply. 3 times 3 is 6. 6 does not exist in base 5, so let's convert it to base 5. That's 1, remainder 1. So I have a 1 here and a 1 here. Then we'll multiply 4 times 2, that's 8. 8 does not exist in base 5, that's 1, remainder 3. Put a 1 here and a 3 here. Then we'll multiply 3 times 3, that's 9. That does not exist in base 5. That's 1, remainder 4. 1 here, 4 here. Then we'll do 4 times 3, that's 12. We'll convert that to base 5. That's 2, remainder 2. 2 here, 2 here. Now to get our answer, we're going to add our diagonals. Here we'll start with this first number here. We'll bring down the 2. We're adding our diagonals. So that's a 2. Then we'll add 3 plus 2 plus 4. 3 plus 2 plus 4, that's 9. 9 is 1, remainder 4. So I'm going to put a 4 here, and then I'll carry that additional 1 to this other diagonal here. 1 plus 1 plus 1 plus 1, that's 4. And then in the end, we bring down that 1. So here is our solution. You read it from here to here. So my solution is 1, 4, 4, 2, base 5. Now let's check that with part A, question 1. Is that the same answer? Yes, it is. So we know we did this problem right. So let's try it again for question 2. Since we have 3 digits on the top, I'm going to make sure I expand my box a little bit bigger. And then we have 2 digits on the bottom, so we only need 2 here for the row. We'll draw our diagonals. And then we can start. So the number on top is 1, 2, 3. And the number on the side here is 2, 1. So let's begin the multiplication. 1 times 2 is 2. So we'll put a 2 here. There is a 0 up here. There is no number in the next position. There's only a remainder of 2. Then we'll multiply 2 times 2, that's 4. We'll put a 4 here and a 0 here. 3 times 2 is 6. 6 does not exist, so we'll convert it to base 5. That's 1, remainder 1. 1, 1. Then we'll multiply. 1 times 1, that's 1. 1 times 2, that's 2. 1 times 3 is 3. So we'll put a 0 and a 3 here. Then we will add our diagonals. This one is a 3, bring down the 3. 1 plus 0 plus 2 is 3. 1 plus 4 plus 0 plus 1, that's 6. 6 does not exist, but we know that's 1, remainder 1. So we'll put a 1 here and carry that 1 over to here. 1 plus 0 plus 2 is 3. and the 0, we don't need to do anything with that. So here's our answer. Our answer is in that jelly bean. It's 3, 1, 3, 3, base 5. Now let's check our work with the previous part. Is that the same answer? Yes, it is, so we know we did this problem right. In part C, I want you to try these on your own and use any algorithm that you like. Try some with the standard algorithm and try some with the lattice method. So give it a try and pause the video. For question number 1, I want to use the standard algorithm here, but remember the lattice algorithm is going to still give us the same answer regardless. We'll write this out, 2, 1, 2, and 1, 1 here. Now remember this is base 3, so I can only have a 0, 1, or 2, that's it. There's only 3 symbols in base 3. So let's multiply. 1 times 2, that's 2. 1 times 1, that's 1. 1 times 2, that's 2. 1 times 2, we're going to move underneath this one. 1 times 2, that's 2. 1 times 1 is 1. 1 times 2, 2 again. So let's add. I have 2. 3 does not exist in base 3. So we'll divide that by 3. That's 1, remainder 0. We have a 0, and I'll carry that 1 over. 1 plus 2 plus 1 is 4. 4 does not exist. We'll divide that by 3. I get 1, remainder 1. I have a 1. Carry that 1 over. 2 plus 1 is 3. 3 does not exist. We'll convert that with a 0, and we'll carry that 1 over. So our answer is 1, 0, 1, 0, 2, base 3. Now let's look at question 2. Let's try a different method for this one. Let's use the lattice method for question 2. For this question, I'll need 4 columns. And I'll need 3 rows. Let's put 1, 0, 1, 1 on the top row. On the side here, let's put 1, 0, 1. Don't forget your diagonals. And now we can multiply. 1 times 1 is 1. We'll put a 1 here and a 0. 0 times 1, that's just 0 for both of these. 1 times 1, we'll put 0 and then a 1 here. 1 times 1 is 1 here and a 0 here. Well, 0 times anything is 0, so we'll put zeros in all of these. I forgot this diagonal down here, so I'll add it now so we don't mess up. And then we could restart the problem. 1 times 1, that's 0, 1 again. 1 times 1 is 0, 1. 1 times 0 is 0, 0. 1 times 1 is 0, 1. Now we could add our diagonals starting from the back. This is 1. This is 1. This is 1. This is 2. But 2 does not exist base 2. 2 divided by 2 is 1, remainder 0. So I'll have to put a 0 here and then carry that additional 1 over to here. This becomes a 1, and then we'll bring down this 1. Now we can find our answer, and let's write it out. Our solution is 1, 1, 0, 1, 1, 1, base 2. And so the lattice method is actually pretty convenient because we don't have to make sure it's stacked properly, then add. So this is also a good method to do. We just have to make sure we draw our lattice correctly. Question number 3. I'm going to decide I like the lattice method for this one, but then again, it doesn't matter what method you use, you'll still get the same answer. I need 3 for the column, and then we'll put 4, 3, 2 on the top. For the rows, I also need 3 rows, and we'll put 2, 3, 1 here on the side. We'll draw our diagonals. And now we could begin to multiply. This is base 5, so we'll start 4 times 2, that's 8. 8 does not exist, base 5, so divided by 5, 1, remainder 3. Put the 1 and a 3. 3 times 2 is 6, does not exist in base 5, that's 1, remainder 1. 2 times 2 is 4, that does exist, so we'll put a 0, 4. Next row, 4 times 3 is 12, 12 does not exist in base 5. This is equivalent to 2, remainder 2, so we'll put 2 and a 2. Next is 3 times 3, that does not exist in base 5, so I have 1, remainder 4, 1, 4. Then we'll do 2 times 3, that's 6, but I know that's just 1, remainder 1, we already done that. And now we'll do the bottom row, which is pretty nice, it's a 1. 1 times 4 is 4, so we'll put a 0 here and a 4 here. 1 times 3, that's 3, so we'll put a 0 and a 3. 1 times 2 is 2, we'll put a 0 and a 2. Now we can add our diagonals. This is a 2, 1 plus 0 plus 3, that's 4. 4 plus 1 plus 4 plus 4, that's 13. 13 does not exist. 13 divided by 5 is 2, remainder 3. Put a 3 here, carry that 2 over. 2 plus 1 plus 1 plus 2, that is 6. 6 does not exist, but I know that's 1, remainder 1. Put a 1, carry that 1 over. 2, 1 plus 1 plus 3 plus 3, that's 7. 7 does not exist, but that's 1, remainder 2. So I'm going to put 2 here, carry that 1 over. Then we'll bring this 2 down, because 1 plus 1 gives me the 2. Now let's write our answer. This is our solution. 2, 2, 1, 3, 4, 2, base 5. So practice the lattice method. Make sure you know how to do it for example 3. For example 4, I'm going to stick with traditional for this question. Remember, we're talking base 6 in this question, so the only symbols are 0, 1, 2, 3, 4, 5. We're looking at base 6 here. 2 times 5 is 10. 10 does not exist in base 6. We'll divide it by 6. That's 1, remainder 4. Put a 4 here, then carry that 1 over. 3 times 5 is 15, plus 1 more, that's 16. 16 does not exist in base 6. So we'll divide that by 6. I get 2, remainder 4. So we'll put a 4 here, then carry that 2 over. 5 times 5 is 25, plus 2 more, that's 27. 27 does not exist. Divide that by 6. I get 4 remainder 3. Put a 3 down here, and then we'll carry that 4 to the front. So we have done our first multiplication with the 5. Then we'll erase these numbers on the top so they don't confuse us, and we'll try the process again. This time we'll start with the 2. 2 times 2 is 4. 2 times 3 is 6. 6 is equivalent to 1 remainder 0. So we'll put a 0 here, and then we'll carry that 1 over. 2 times 5 is 10, plus 1 more is 11. 11 divided by 6 is 1 remainder 5. Put a 5, carry that 1 over. Then we can add 4. 4 plus 4 is 8. 8 does not exist. Divide that by 6. I get 1 remainder 2. Carry that 1 over. 1 plus 3 is 4. 4 plus 5 is 9. 9 doesn't exist. But I know that's 1 remainder 3. Put a 3 here. Carry that 1. And then a 2. So finally, our answer is 2, 3, 4 to 4 base 6. A lot of work, but definitely doable. Just take your time, be careful. Practice these again after you watch the video. Now let's move on to dividing different bases. Let's look at 416 divided by 7. Now you know how to do this. You put the 7 on the outside, the 416 on the inside. Then you ask, 7 times what gives you 4? Well, nothing. So you leave it blank. Then you ask, 7 times what gives you 41? Well, the most I could do is 7 times 5 is 35. That's the closest I can get. So then you put a 5 up here, and then you multiply 5 times 7, that's 35. Then you subtract. To subtract, you have to borrow, so that becomes a 3, this becomes an 11. You subtract it, you get 6. Then, what do you do next? You bring down that 6, and then you repeat the process. 7 times what gets you close to 66? So we know the closest I can get is 7 times 9, that's 63. So you put a 9 up here, and then you multiply. 7 times 9 is 63, then you subtract, you get a 3. Now 7 doesn't go into 3, and there's nothing else to bring down, so you put remainder 3. So our answer is 59 remainder 3. So that's how we do it in base 10. Now let's try it with different bases. Example 2. Now I want the 2 to be in the front and the 312 to be on the inside. Now this is base 4, so the only symbols are 0, 1, 2, and 3. Before I do this, I want to look at all the multiplications with 2 in base 4. So let's look at it. 2 base 4 times 0 base 4. Well, that's just 0. That's definitely something we know. Now we'll do 2 base 4 times 1 base 4. Well, that's equivalent to 2. Then we'll do 2 base 4 times 2 base 4. That's equivalent to 4, but 4 does not exist in base 4. 4 divided by 4 is 1 remainder 0. So this is equivalent to 1, 0 in base 4. Then we'll do 2 base 4 times 3 base 4. This is equivalent to 6, but 6 does not exist. If I divide that by 4, I get this is 1 remainder 2. So this is equivalent to 1, 2, base 4. Remember, all of these are in base 4. Now, since we have all the multiplications written out, it's easy to do the division. Remember, all of these are in base 4. Okay, these are all in base 4. So let's divide. 2 times what gives me very close to 3? Well, if you check, if I do 2 times 1, that's very close to 3. If I do 2 times 2, that's way too big. So we're going to do 2 times 1. So we'll put a 1 up here, and then I'll multiply. 1 times 2. Well, that's equivalent to 2 in base 4. So let's subtract. I get a 1. Then I bring down the 1 over. Now we're going to figure out 2 times what gives me very close to 1, 1, base 4. Well, if I look at my chart, if I go 2 times 3, that's too big. If I go 2 times 2, that's pretty close, so we'll use a 2. So let's put a 2 up here. Multiply 2 times 2, that is going to give us 1, 0. We already know what 2 times 2 is. It's 1, 0. So we put a 1 here, and then a 0. Let's subtract. 1 minus 0 is 1. 1 minus 1, that's just 0. Then we can bring down that 2. So this is going to give us 8, 1, 2. Now 2 times what gives you very close to 1, 2? Well, it's exact. This is a 3. I know 2 times 3 is 1, 2, base 4. So we're going to put a 3 here, put a 2 here, then we'll multiply. 2 times 3, I know that's 1, 2, base 4. Subtract. We do not get a remainder. We get a remainder of 0. So here's our answer. 1, 2, 3, base 4. So the secret for this question is to make sure you put all of the multiplications with your divisor in base 4. Then you could do the long division. In example 3, let's put 4 on the outside and 223 on the inside. Remember, all of these are in base 6. So the only symbols are 0, 1, 2, 3, 4, 5. Since I'm using 4 as our divisor, I'm going to look at all of the multiplications with 4 in base 6. We'll have 4 times 0. We'll have 4 times 1. We'll have 4 times 2. We'll have 4 times 3. We'll have 4 times 4. We'll have 4 times 5. And remember, all of these are in base 6. Alright, so let's get started. 4 times 0, that's 0 in base 6. 4 times 1, that's 4. 4 times 2 is 6, but 6 does not exist in base 6. I'll do the scratch work here. That's 1 remainder 0. So that's 1, 0, base 6. 4 times 3 is 12. 12 does not exist in base 6. That's actually 2 remainder 0. So that's 2, 0, base 6. 4 times 4 is 16. 16 does not exist. 16 divided by 6 is 2 remainder 4. So that's 2, 4, base 6. 4 times 5, that's 20. 20 does not exist. So we'll divide that by 6. That's 3 remainder 2. Or 3, 2, base 6. Now we got all of the scratch work out of the way. We can do the problem. 4 times what gives you close to 2 in base 6? Well, the closest I can get is a 0. So we can put a 0 up here if you want. That's perfectly fine. Then we'll move on to the next two digits. 4 times what gives me close to 2 base 6? Well, the closest I can get without going over is 4 times 3. So we'll put a 3 here. Then we'll multiply 3 times 4. 3 times 4 in base 6 is 20. Subtract. I get 2, and then this is a 0. Bring down the 3. So now we get 23 in base 6. 4 times what gives me close to 23 without going over? I have 4 times 3 is the best I can do. So we'll put another 3 up here. Then do 4 times 3, that's going to give us 20. Subtract, I get 3. There's nothing else to bring, and 4 does not go into 3. So we have a remainder. Our remainder is going to be 3. So make sure you write your answers properly. This is all in base 6. So let's write our official answer. 3, 3, base 6, remainder 3, base 6. So here's our solution. 3, 3, base 6, remainder 3, base 6. Let's try example 4 now. This is base 5. Again, I'm going to put the 3 on the outside and the 104 on the inside. This is base 5. So we'll have to look at all of the multiplications with our divisor 3 in base 5. I'm going to multiply 3 times 0, 3 times 1, 3 times 2, 3 times 3, and 3 times 4. Remember, we're talking base 5, so the only symbols are 0, 1, 2, 3, 4. There are no other symbols. So we'll have to stop here. Now what's 3 times 0? That's 0. 3 times 1 is 3 in base 5. 3 times 2 is 6. 6 does not exist in base 5, so we'll convert that. That's 1, remainder 1. So that's 1, 1 in base 5. 3 times 3 is 9. 9 does not exist. Divide that by 5. I get 1, remainder 4. So that's equivalent to 1, 4 in base 5. 3 times 4, that's 12. 12 does not exist in base 5. That's 2, remainder 2. 2, 2, base 5. Now we could do the long division. 3 times what gives you close to 1? Well, the closest I can get is 0. 3 times what gives you very close to 1, 0 in base 5? Well, the closest I can get is 3 times 1. So we'll put a 1 here. Then we'll multiply. 1 times 3 is 3. Now we'll subtract. Remember, this is base 5. So when I subtract from the 0, I have to borrow. Since this is base 5, I add the 5. Since I'm borrowing from the 1, this is a 5 in base 5. So 5 minus 3 gives us 2. Remember, this is base 5. We don't borrow a 10, we borrow a 5. Then we'll bring down the 4. 3 times what gives us close to 24 in base 5? The closest I can get is 3 times 4. So we'll put a 4 here. Then multiply. 3 times 4 is 2 in base 5. Subtract, I get 2. 3 does not go into 2, so we'll write down our answer. This is going to be 1, 4, base 5, remainder 2, base 5. So let's write down our official answer. 1, 4, base 5, remainder 2, base 5.